they'll go flowing by. So let's just do a quick demonstration of that as well, as long as we're at it here. So I'm going to do sip set debug on. Now, if I were to just sit here for a minute, you'd actually see the phone come back and re-register, and you'd see that SIP message. But since I don't want to sit here for 5 minutes and just have an awkward silence, we'll go ahead and make a call here and see what happens. Okay, I'll go ahead and hang it up here. So if we scroll up here, you'll see some different SIP messages came through here. So here was a few more up here. There we go. Okay. So here we had the initial invite. And there's the Sdp in that message, talking about the different audio formats that were supported, MULA and ALA and G729. And Asterisk came back and responded with what? Right here? Unauthorized. Because the phone didn't supply a username password. It didn't try to authenticate to Asterisk. And so Asterisk says, I'm sorry, come back with a username and password. And then the phone here sends an acknowledge message saying, okay, I got your message. I'll try again later. I'll do the right thing next time. This time it sends an invite again, but this time embedded in here is some authorization information. The username, phone 1 in this case, and a hash of the password. So it's a challenge response type system. So it's not sending your passwords in plain text, thank goodness. Okay. This time, Asterisk responds back with, as soon as it gets done here, it sends back a 100 trying. Let me get back to the beginning of the line here. So here's the 100 trying. It says, I'm trying to do that. Then it starts going out and ringing that phone, and then sends a 180, a provisional message saying, hey, I'm ringing that phone. It's trying. And then when I hung up the phone, it sent a cancel message saying, never mind. We don't want to make that call anymore. Does that make sense? So if you understand the SIP protocol, and again, I don't expect everybody's experts on the SIP protocol yet, but that's something you can study in your own free time. You can really dive into the lower levels of messages within the SIP signaling protocol and find out exactly what's going on. Okay? We're done here. Now to turn that off, we can say SIP set debug off. Unturn that off.
When you set the debug to on, does that go to the log here then? Or not?
It does.
And when you turn it off, then it stops?
Correct. If you have the verbose messages going to the log file. Okay? Now, what if you wanted to debug just one particular phone? You didn't want to see all the SIP messages from all the phones on your system. You just wanted one particular phone. You can say SIP set debug peer phone 1. Or you could say SIP set debug IP, whatever that IP address was. Or SIP set debug off to turn those all back off. Okay? So again, that's the SIP protocol. You can do the same thing for the other protocols within Asterisk. If you want to do EEX, say EEX2 set debug on, EEX2 set debug off. If I had a PRI on here, I could turn on PRI debug and see all the D channel messages come through. Anybody here do a lot with PRIs? Wouldn't it be nice if you could see all those D channel messages coming through and not have to hook up a T-Bird and have all that expensive equipment? Well, yeah, you can do that with Asterisk too. Told you it wasn't just a PBX. Now it's a protocol analyzer. Okay? Yeah, and again, with Asterisk, it doesn't care. It's just data. It can print it out. So kind of fun stuff. Yes, it'll do SS7 too. All right. So that's a little bit about turning on the debug for the kind of the next layer there. Some things you may want to just go learn on your own. Spend some time playing around with. Watch the SIP protocol. Learn to recognize different types of messages in the SIP protocol. The invite sequence is very important, and the register invite is very important. And if you can, take the time to learn how the authentication piece of that works. Again, typically a phone will send a call to Asterisk. Asterisk will reject the call. The phone will come back and say, okay, I acknowledge that. Come back with a new invite, this time with the username and hash of the password. and then asterisk will authenticate that and continue on with that. Okay. There's some slight differences between in the way the authentication works between a register and an invite. That's a little more trivia than anything else, but there are some slight differences there. Note that authentication is one way. In this case, the phone is authenticating to asterisk. Most voice over IP phones will accept calls from anybody and only do authentication on the outbound side. So be aware of that. It's fun to play pranks on your coworkers if their phones accept calls from anywhere, but yeah, I'll leave it at that. A couple other things that you may have seen as we were doing that message, and I'll pull this back up so you can see it as I talk about it. Did you notice in these SIP invite messages, I pointed out the Sdp section. Let me see if I can find an example of one here. Here we go, right here. So in the SIP message, there's this section here called the Sdp section, and this section talks about the different audio formats that this session will support. In this case, it's saying PCM audio MU-LAW format, 8,000 samples per second, PCM audio and A-LAW format, 8,000 samples per second, and G729 audio, 8,000 samples per second. Again, remember that the SIP protocol, SIP is taking care of the signaling, and in this Sdp message, it's talking about the audio formats that it supports. The audio is actually transmitted using another protocol called Rtp. Okay? So learn to look for this Sdp section in an invite and understand what are the different offers for different media types that are being offered there. The other thing to understand is the Rtp, the Rtp protocol itself. And if you want to, an asterisk, we can actually turn on Rtp debugging as well. We can say Rtp set debug on. And then when we make a SIP call on the system, it's going to tell us, hey, I send a packet. Oh, I got a packet. Ooh, I send an audio packet. Ooh, I got an audio packet. Ooh, I send a packet. Got an audio packet. Now, most of the time, that's really redundant, right? You don't need that 50 packets per second scrolling across your screen. But sometimes if you're saying, let's say you have a situation where you're getting one-way audio, where audio is getting through to one party, but the other party can't talk back. You can look in that and say, hey, are we getting Rtp packets back from that other phone? And 9 times out of 10, it's a firewall issue, and the return audio isn't coming back through the firewall. Nobody's ever had that problem, right? No, never. We'll talk about that a little bit later in the presentation if we have time as well. But again, these are some of the sorts of things we can do with the debugging messages. And again, Rtp set debug off to turn those back off. All right, any questions on this part so far? Question over here.
When you said when you show here,
Sure. When you type SIP show peers, there's a far column that says, is it monitored? What you can do is you can add a setting to your sip.conf file for a particular peer to tell asterisk that, hey, every once in a while, go ask that device if it's alive, if it's responding. And that's what's called a qualify setting. Let's go ahead and take the time to do it here. As long as we're having fun, let's have fun here. There we go. And so I'm going to go into sip.conf. First of all, let me show you without. So we do a sip show peers. And you notice that it says unmonitored. Sorry, it kind of wraps. But you see how it says unmonitored there? It means we're not actively going out to try to find out if that device is responding or not. Now if we go into sip.conf, if I can type, and we go down to our phone here and we say qualify equals yes, save that, do a sip reload. Now if we do a sip show peers, it says, hey, the last time we pinged that phone to say, hey, are you alive? It came back and responded within 20 milliseconds to say, yeah, I'm here, I'm responding. It's not an ICMP ping. It's actually a SIP packet. It's a SIP options packet in the SIP protocol. In the EEX protocol, it's a poke packet. Different protocols use different methods to say, hey, are you alive? But in this case, it's actually a SIP options packet saying, hey, if I were to make a call to you, what would you do with it? And the phone's coming back and says, it'll either say, yeah, I would take that call, or the phone would say, hey, go away. But either way, we have our response, and we know that phone is out there and responding. If for some reason we unplugged that phone and waited a minute, we would see that, hey, we had tried to do that ping, and all of a sudden that's not responding anymore.
Is it a good practice to have that monitor?
It's kind of a double-edged sword. The question is that a good idea to do, yes or no? The nice thing is you can tell at a glance, hey, which devices are responding and which devices aren't. The bad side of that is, let's say you have 1,000 phones on your network. Every minute, on the minute, Asterisk is trying to send a big storm of packets out to each of those devices to say, hey, are you responding? There's some things we have in the SIP channel driver now to kind of spread those out, so it's not just a shotgun approach to sending out those qualify messages. But in a large-scale environment, you probably want to turn those off. In a small-scale, especially testing environment, yes, turn it on. That answer your question? Okay.
Qualified on. The default is 20 milliseconds.
The default is that if it takes less than 2 seconds for the device to respond, then everything is okay. It's 2,000 milliseconds. We could just as easily go in here and change that. Instead of saying qualify equals yes, we could say qualify equals 500. Saying if the device responds within 500 milliseconds, count that as okay. If it takes longer than 500 milliseconds, treat it as if it's not responding. Okay? In that case, yes is the same as 2,000 milliseconds.
Is that easy to apply to all devices instead of have to put it under each one? If you want to turn on just for debugging for all devices and then turn it back off?
Yes. You can do that with what we call templates. It's a little advanced, but let's take a minute to do it anyway. We're having fun, right? So the way you do a template is you create a section here, and I'm going to call it, give me a good name. Template. Travis. Okay? And after you have the section name, you can put an exclamation mark here to say, this isn't really a real SIP device. This is just a template. Okay? And then you'd put your setting in here, qualify equals yes. Okay? And then you could come back up here to your phone here, and we'll take this out here, and we could say, in parentheses, Travis. That means apply that template to this peer. So anything that was down here in this template would also be part of this phone, and we could apply it here as well. Does that make sense?
If you wanted to be able to turn all on and all off,
right.
You have to have all of them have Travis beside it.
Right, and then you just turn it on and off in the Travis. No, you just set it to no here, and now it applies to all those, and do a reload. Does that make sense? Yeah. So we have a templating engine, so you can do those sorts of things. It's a little, a little outside the norm, but I find it very, very powerful. Great question. Question over here.
Do you have more than one template applied?
Absolutely. Okay, so we need another template called Bob here. Anybody care about network security? That guy does. Hey, Life, how you doing? So what if we wanted to apply, say, an access control list so that people could only call in from certain IP addresses? What a concept, right? So what if we let's add another template here for that. In the Asterisk scripting language here, we can use permit and deny statements to control access control lists. So typically, anybody here do Cisco access control lists? What's your rule for your ordering on Cisco access control lists? Allow, deny. Asterisk is just the opposite, okay? Yay! So we're going to say deny everything. Okay? And that's saying 0.0.0.0 is the IP address with 0 bits in the subnet mask. Or we could do 0.0.0.0. Same thing, right? And then we're going to permit 192.168.101.0 with a /24. Or 255.255.255.0. Okay? So now we've got an access control list. If we want to apply that template to these phones, then we say, oh yeah, we want to apply the Bob template here as well. And now those phones have an access control list applied as well. How would we know? Well, if we go do a SIP reload here, category Travis does not exist. I don't think you do. What am I doing wrong, Life? I don't think it does, but let's try it. Let's try it. Hey, it worked. How about that? Yay. Thanks, Life. I owe you one. One free Fedora CD for you. Yeah. You're down to 9. We're good. Okay. So now, if we do a SIP show peers,